Hi, welcome to this new episode. In the previous episode, we saw that how a disk was given an angular velocity and it was kept on the surface. So initially that was slipping. Due to that slipping, the friction appeared, and due to that friction, what happened? We saw that the translational velocity started increasing, angular velocity started decreasing. A time came when v became equal to omega r, and at that time the pure rolling started, and it remained so forever. Now here I'll take another example. So again, I will not start pure rolling from very beginning, but what I'm going to do is that this is my object which has some mass m and moment of inertia I, let's say radius r. So what I've given is that I have given right now a translational velocity v. So in previous example, again I'll take it as v0. So in previous example, I gave that an initial angular velocity and kept it on the surface. Now what I've given is that I've just given it a translational velocity v0. So like just I have given a v0 and kept on the surface. So what will happen? Tell me. Let's see whether it will slip or not. As you keep it on the surface, what is velocity of this point? The velocity of this point is going to be 0, right? And what is going to be velocity of this point? Because velocity of this point is v0. So velocity of this point, you know that in translation, all the points are same velocity. So velocity of this point is also going to be v0. Now these two, the velocity of this point is 0. So these 2 points don't have same velocity. It means it is slipping. And tell me, if it is slipping, in what direction is it slipping? It is slipping in forward direction, right? So in what direction friction is going to act, and what type of friction is that going to be? That is going to be kinetic friction, and that kinetic friction is going to act in backward direction. And you know that the value of kinetic friction is nothing but mu, and that's simple to find. Now once we know these things, again what we are going to do is that break the motion into 2 parts. So first, translation. We know that initial velocity that I am writing as v initial was given as v0, and let's say this is v at any time as the time passes, any general time t. Alright. Now there is a force acting which is here, mu m. Now tell me, the mass is m. So this mass, initial velocity was given v in this direction, and the force is acting in this direction. What will this force do? Because the initial velocity is in this direction, and whenever velocity and force are in opposite directions, what is going to be net acceleration here? Acceleration is going to be force divided by mass. Is there any other force acting in horizontal direction? No other force, only friction. So, and how that friction came? You give it some initial velocity and you kept it on the surface. As you keep on the surface, slipping starts. As slipping starts, friction acts. So from the very beginning itself, friction will start acting. So what's going to happen here? This acceleration is going to be mu n divided by mass m. So now this acceleration is actually deceleration. You know that initial velocity was v0, at any time t velocity is v, so this velocity v, translational velocity is v, is going to decrease. And understand, when you are doing all this, you are doing translation, don't even bring rotation in your mind. It is not rotating, it is like just a block which is just moving. And the initial velocity was given as v0, and deceleration is mu n by m. So what's going to happen? Its velocity v is going to decrease as time passes. So final velocity is initial velocity minus acceleration mu n by m into t. So this is how the final velocity is going to look like. Now let's look at the rotation part. So let's say this is the disk which is initial angular velocity. So omega initial was 0. There was no initial angular velocity given. So this is omega as the time passes. And the force was acting like this. What was the value of this force? You know that the value of this force was mu n, and there is going to be this is going to be r. So what's going to happen here is that this force is going to produce a torque. How much torque this force is going to produce? Mu n into r. And see in what direction this force is producing the torque. This is producing the torque in clockwise direction here. And initial angular velocity was 0. So because there is only torque, so what this torque is going to do? This torque is going to produce alpha. So alpha is tau by I. You know tau is I alpha. So that is mu n r by I. These are not formulae that you need to remember. Nothing. Just remember the concept. There is a force. Due to this force, there is a torque, and that torque is going to increase the angular velocity. So what is going to be final angular velocity? Initial is 0. So 0 plus alpha t, which is going to be equal to mu n r by I upon t. So this is how omega. Now you see one thing, that omega is increasing as the time is passing and velocity is decreasing as the time is passing. And again I'll tell you what is the net velocity of this point of any rolling object. At any time, if this is v and this is omega and the radius is r, we know due to translation v and due to rotation omega r, so net velocity of this point is v minus omega r here in this case. And we again understand that v is decreasing. You can see here v is decreasing and omega is increasing. A time, that's why v is decreasing, omega is increasing. That's why a time will come when v will become equal to omega r. So in this case also that beautiful thing is again going to happen. Once v becomes equal to omega r, the net velocity of this point is going to become 0, right? Once the net velocity of this point becomes 0, the velocity of this point is also 0. So these 2 points will have same velocity. And after that, what will happen? Because at same velocity, pure rolling will start with v, the value of v equal to omega. So that's the simple concept that we got. In previous case also we saw that we gave an angular velocity and kept it on the surface. After some time, pure rolling started. Here also we gave it a translational velocity and kept it on the surface. We saw that due to translational velocity there was slipping. Due to slipping in forward direction, friction appeared in backward direction. This backward friction started decreasing the velocity, but this backward friction started increasing omega, and that's why the net velocity of this point, which is at any point, if this is v and this is omega, this is v minus omega, we know that initially omega was 0, so what was net velocity of this point? Only v naught. Initially there was only v naught here, alright? But as time will pass, v will decrease, omega will increase, the time will come when this will become 0, and at that time again friction will become static. And since there is no other force, that's why the value of that static friction is also going to be 0. And again the pure rolling is going to keep on forever. So that's a beautiful concept that we saw. We gave it a translational velocity, and after some time what happened? It started pure rolling. So generally what type of questions they ask is that they will give you some, they can ask only 2 types of questions. First type of question, they will give you some omega, keep on the surface, and they will ask you, tell me after what time the pure rolling is going to start. Second type of question, they are going to give you an omega and keep it on the surface, and they are going to ask you, tell me after what time the pure rolling is going to start. I hope that I said different things, so I'll just repeat again. They'll give you an omega, keep on the surface, and ask after what time pure rolling will start. And the second case that we discussed here, they're going to give you some translational velocity, keep it on the surface, and then ask that, tell me after what time pure rolling is going to start. So now these 2 types of problems we are going to see in next 2 episodes. So please follow on. Have a nice day.